Jai Hind everyone, I am Vaishali Rastogi, Assistant Professor at Department of Computer Science and Engineering at Akgec Garg Engineering College. Today I am having the topic of deadlock concepts. So let's start with the introduction first, and first we will go through with the content of the today's program. So here today we are going to discuss first about the deadlock, then conditions for deadlock, deadlock detection, prevention and avoidance. Next we are having topic starvation, and last we will discuss about advantages of deadlock and disadvantages of deadlock. Let's continue with the deadlock first. First you should know why we are using deadlock. What is the concept of deadlock in operating system? Deadlock is something, a situation. Here you can see a full definition of deadlock. Deadlock is a situation where each of the computer process waits for a resource which is being assigned to some another process. In this situation, none of the process gets executed since the resources it needs is held by some other process which is also waiting for some other resources. Okay, so here you can see that deadlock is a situation. What kind of situation? Where all the process requires some kind of resources which is already held by another process. So next we can say in other words that a deadlock is a situation in which two computer programs sharing the same resources are effectively preventing each other from accessing the resource, resulting in both programs ceasing to function. Means if I am having a single resource, you can say this pen, and so many teachers wants to access this pen to teach at the same time, and pen is only holding right now by me, and another faculty will come and ask to that they want this pen to execute or to deliver any lecture in another room. So this kind of situation, because this pen is already held by me and another faculty is waiting for the same pen, this kind of situation in general life we can say as a deadlock. So in earliest, if we are talking about the computer language, earliest computer system where we are using so many operating system having this kind of situation in a very normal nowadays. So these kind of operating system ran only one program at a time. All the resources of the system were available to this one single program. Later operating system run multiple programs at once, interleaving them. Means here let's suppose I am having a single resource and so many processes. Process 1, 2, process 3 and process n. Here I am having so many processes, process 1 to process n. These all processing. Yes, okay. If you have any query, you can write in the chat box. Okay. Tarun, Shantanu, Avinav, Arjun and Shadab. Jai Hind beta. If you have any query, you can ask. Okay, so where we were talking about? We were talking about the deadlock situation. So deadlock is a situation, as I have told you, that there is a single resource and so many processes are requesting for the same resources, and this resource is already held by P2. Means currently P2, this process is having control of this resource on completely, and this resource is completely reserved by this process, and other processes are waiting for the same resource. They also want to execute their task with using this resource. This kind of situation in technical word we can say as a deadlock. So deadlock basically are programs where we require to specify in advance what resources the process needs and what kind of avoidance we can use, any kind of approach to reduce this kind of problem. So this is also a good example of dynamic allocation of resources. Means if we are having a limitation of resource, this situation always comes in that kind of problem. Wherever we are having limited resources and processes are more than the resources, then this condition, the resource have to share itself among all these processes, and all the processes are saying that they want the resource first. So this kind of situation always lead to the deadlock. In this scenario, you can see Here we are having some kind of resources R1, R2 and R3, and some processes which are P1, P2 and P3. So here you can see, let us assume that there are 3 processes, P1, P2 and P3, and there are 3 different resources, R1, R2 and R3. R1 is assigned to P1. Okay, here you can see R1 is assigned to P1, means this resource is already allocated or held by this P1 process, and after some time P1, the same process also requires for R2. Okay, so it is requiring R2 here, and which is R2, this resource is already held by P2, means P2 process is already using R2 resource, P1 process is already using R1 resource, and P3 process is already using R3 resource. So these processes are using the same resources, but on the same time they all processes are requesting the other resources which is held by another process, means P1 is also already held R1 and P1 is required R2. So this is just showing this kind of arrow. The direction of arrow is showing that this process is already held R1 and this is requiring for R2, which is already held by P2. And in the last, P3 is already held R3 and requiring for R1. This is the complete description in a graphical way, you can say that. This is the complete description of deadlock. Okay. So I think you have understood the concept of deadlock in a technical term. If you have any query, you can write over here. So let's sum up all these definitions. Deadlock is a situation that occurs in operating system when any process enters a waiting state because another waiting process is holding the demanded resources. Means a situation where so many processes are already held or hold some resources and also in a waiting state. These 3 processes already waiting for some kind of resources, and these all processes also holding some resources in the same time. This kind of situation we can say as a deadlock. So deadlock is a very common problem in multiprocessing where several processes share the specific type of mutually exclusive resources known as soft lock or software. Means if we are having some kind of multi-programming or multi-processing operating system where so many processes are running on a simultaneous way. So here all the processes are requiring some kind of resources. So this kind of situation, because we are having a multi-programming or multi-processing operating system and so many processes we can run on a same time. In this kind of situation, we can see that the same resource is requesting by number of processes at the same time. So here the deadlock condition always occurs. So we have some methods to deal with the deadlock. We will continue in another slides of the how we deal it or how we detect it. So we will continue over it. Okay, Anshita. So I also want to give you a good example of deadlock. You can see here in this diagram. It's the diagram of a road. Okay. You can see there is a road which is completely two-way by this up to this part, and it here also two-way up to this part. But here this small part is narrow comparatively to other both parts, and you can see over here that here one car can move in this same direction and another car can move in the opposite direction at the same time. Means it's a two-way lane. And here you can see it's also a two-way lane where these kind of car can move in a both direction at a same time. But this portion, this portion is showing you that there is a narrow way and there is a limited capacity of moving car. Means only one car can move in a single direction. It can be from this to this side or this to this side. It depends. Okay. So wherever we are having condition that there is a narrow road and we have to move in the opposite direction, at the same time two cars are coming from this direction and towards this direction. This situation is showing the deadlock problem. Okay, so a real world example would be a traffic condition which is going only in a one direction. Here this we can also call it as a bridge. You can see in a real life location whenever you travel, sometimes we face a very good n number of lanes road, but sometimes we have to move by a single lane bridges. Okay, so several cars can go and come, but in this specific area only one car can move in a single direction. So here in this example I can say that this particular bridge is a resource and these cars are the processes. These cars required this bridge to complete their task, to move from here to there, and for this they required this bridge, this resource. Okay, so this bridge is using by all these cars, means n number of processes are using the same resources. But at the same time, if more than one resource is requesting for the same more than one process is requesting for the same resource, and also this resource is occupied by someone else, some else process. So in this situation we always see the deadlock in the real life. We can take a good example on red light signals. Let's suppose this is any red light area where you can hear a traffic light is there every direction. Wherever we are having some cars moving in the same direction, here the same, if let's suppose if this signal gets down for some time, what will happen? Every car will come to execute their task, means every car will start and they will not think about other three sided, they will just try to complete their task. Means in this situation, if the lighting is not working, traffic light is not working properly, then this situation all the car can say that I want to go first. So this kind of situation, this resource area is can be requested by n number of cars at the same time. At this kind of situation we can say that this is the concept of deadlock in the real life situation. So let's move forward. First we should know what are the necessary conditions for deadlock. Okay, so what are the necessary condition deadlock? Because if deadlock is happening inside our system, there are some situations. Without that situation, deadlock would never occur. So there are four necessary conditions for deadlock. First is mutual exclusion, hold and wait, no preemption, and circular wait. So what is mutual exclusion? We should know first. Mutual exclusion is a state, is a situation. There must exist at least one resource in the system which can be used by only one process at a time. Means what mutual exclusion says, that there is an area or resources, a single resources, a resource can be used by a process at a single time. Means only one process can use this resource at the single time. No more than one process can use this same resource at the same time. This kind of situation or concept we call as a mutual exclusion. If there exists no such resources, then deadlock will never occur. Printer is a very good example of resource of this mutual exclusion concept. Let's suppose it is a printer. It is a printer and we are having n number of system connected to this printer, and all the systems are giving a command to printer that print my page. Okay, this can be 1, 2, 3 and n. All the system are saying to the printer or commanding to the printer that please print my request first. What will printer do? Printer just, if the printer is already acquiring by system number 1, so it is printing the pages which is given by printer number 1. It will print all the pages, all the requests by print system number 1, then it will accept another request. This kind of situation is a very good example of mutual exclusion. Means a single resource is completely utilizing by a single process. No one can use until it is finishing up with the single process. Okay, so it is the concept of mutual exclusion. So if you have any query with the mutual exclusion, you can ask over here. So second one is hold and wait. What is hold and wait? You can learn it by the name only, that hold and wait. Okay, so it will denoting that if a resource is holding by a single process, sorry, P process, it is holding, the process is holding a resource and also waiting for another resource. Okay, if the processes are holding a single resource and also waiting for another resource to complete their task, this kind of situation we can call it as a hold and wait situation. Okay, so this is the second condition which should be fulfilled by the processes if there is a deadlock. Okay, so there must exist a process which holds some resources and waits for another resources held by some other process. Means it is waiting for this resource and this is already held by another process. Means it is already having R1 and it is waiting for R2 which is already occupied by P2 process. So this is our second situation. Let's move forward the third one. Third one is says that no preemption. What is no preemption? No preemption means no interruption. When a process is dealing with another resource, then it will not get preempted. Okay, so once the resource has been allocated to the process, it cannot be preempted. Okay, R2 is already allocated by P2. It cannot be preempted because P1 is waiting for R2. No, I can write it very clear. P1 is already R2 is already held by P2 and it will not get preempt and will be allocated to P1. Why? Because there is a no preemption condition. R2, if R2 is busy with P2, then it will not get preempted. Okay, it means resource cannot be snatched forcefully from one process and given to the other process. The process must release the resource voluntarily by itself. If P2 is already completed its task, then it can release R2 and it can be allocated to P1. Okay, this can happen, but we cannot do it forcefully. We cannot force R2 that if you have not completed your task, you just release your resource and just come to me. Okay, and the last one is saying that circular wait. What is circular wait? Wait, we all know that some process is waiting for another resources. What is circular wait? Circular wait is says that there are four processes, P1, P2, P3 and P4. Let's take an example. There are four processes, P1, P2, P3 and P4, and all these processes are waiting for each other to be completed. This kind of situation we can call it as a circular wait. Means P2 is waiting to be complete for P2. P1 is waiting to complete for P2 and P2 is waiting to complete for P3 and P3 is also waiting to complete for P4 and P4 is also waiting to complete for P1. Means if P1 have to execute their complete task and it is also requiring P2 process, and P2 is also in a still wait condition and it is waiting for P3 to be complete, and P3 is already requesting for P4 to complete. If P4 is not getting complete, P3 will not get complete. P3 is not get complete, so P2 will not get complete. This kind of situation, the circular wait, all processes are waiting to get complete for everyone. This kind of situation we call it as a circular wait. So all these four requests or condition should be satisfied if there is a deadlock. Okay, so these are the four Yes, Anshita. Ma'am, does no preemption applies to mutual exclusion also in reference to system printer example? Yes, because printer is already engaged with P1, system 1. There is no preemption, okay, and it is all the system are also waiting for to complete, and no preemption is there. That's why it is not releasing system 1's request. Okay, if there is a preemption condition, that it will get preempted due to the priority of another system. It is not looking for the priority. If system 3 is having higher priority than the system 1, then it will not get preempt because no preemption is there. Okay, so I hope, Anshita, you have got your answer. If you have any query more, then you can ask it. Okay, so let's continue with the deadlock detection. So a deadlock occurrence can be detected by the resource scheduler. How we will detect that deadlock is there or not? It always be detected by the resource scheduler. What is scheduler? Which is basically scheduling the resources to the processes. This is basically the resource scheduler. Means all the resources, resource 1, 2, 3 are scheduled by resource scheduler. Okay, so then resource scheduler can detect that there is a deadlock or not, because it knows that what kind of process, which process is requiring which resource. So resource scheduler can detect the deadlock. A resource scheduler helps OS to keep track of all the resources which are allocated to different processes. Okay, so it always helps to operating system that it can keep track of resource 1, 2 and 3, that these resources are where they are requested by which process and where it is already allocated. So RS is plays very great role in this. Okay, for more about deadlock detection, I will go with another session. So I will discuss it more in another session. Here I am just giving a brief introduction of what is, how we will detect, how we will avoid and prevent. Okay, so here you are just getting a small introduction or small concept of deadlock. In another session I will discuss it in detail. So next we are having deadlock prevention. What is deadlock prevention? Prevention means that to prevent means here we will just try to prevent that there should not be a deadlock. Okay, we will try that there should not be any situation will happen that it will lead to the deadlock. So it's a very important to prevent a deadlock before it can occur. Always deadlock prevention always happens before the occurrence of the deadlock. The system checks every transaction before it is executed to make sure it does not lead to the deadlock situation, such that even a small change to occur that deadlock that can operation which can lead to deadlock. In the future it can also never allow to process to execute. Means here we will see if we are having any request from P1 or P2 and P3, here we will always see that the process which are coming to the operating system, it is requesting for the resources, it is creating any kind of deadlock. This kind the resources it is required, is this creating such kind of situation when deadlock can occur? If there is a requests or processes which can lead to the deadlock, we will always try to neglect. Okay, we will always try to delay or deny that kind of situation, because we don't want in deadlock prevention the deadlock will occur. So it is a set of method for ensuring that at least one of the condition cannot hold. So what kind of condition we should know first? So here you can see what were the necessary condition for that. Again, mutual exclusion, no preemption, hold and wait and circular wait. These were the necessary condition for the deadlock. We will only focus on these 4 conditions, that it should not be happen, because if there is a situation of these 4 if there is a chance of happening of these 4 situation, that will lead to the deadlock. So we will focus one by one all these kind of processes. So first, the no preemptive action. What is no preemptive action? A resource can be released only voluntarily by the process holding it after that process has finished its task. Again, if a process which is holding some resources requests another resource that can't be immediately allocated to it, in that kind of situation, all resources will be released. Preempted resources require the list of resources for a process that is waiting. The processes will be restarted only if it can regain its old resource and a new one that is requesting. If the process is requesting some other kind of resources, when it is available, then it was given to the requesting processes. Okay, so if it is held by another process that is waiting for another resource, we release it and give it to the another requesting process. So this kind of situation occurs under no preemptive action. Okay, so where we will always try that there should not be a situation of no preemption. If a higher priority is coming or an emergency kind of process is requesting for the resource, then if it is releasing the resource, process is releasing the resource, that there should not be a deadlock. So this is a prevention method 1. And next we are moving towards the mutual exclusion. So what is mutual exclusion? We have already learned about mutual exclusion. How we will prevent deadlock using mutual exclusion concept, let's discuss it first. Okay, so mutual exclusion is a full form of mutex. Okay, so what? Mutex. New term, you can read it from here, mutex. So it is a full form of basically mutex. It is a special type of binary semaphore which used for controlling access to the shared resource. Okay, it's the kind of semaphore which always control the access. It includes a priority inheritance mechanism to avoid extended priority inversion problems. It also allows current higher priority tasks to be kept in the blocked state for the shortest time possible. Again, we can say that the resource which is shared, such as read-only files, never lead to the deadlocks. But resources like printer and tape drivers needs exclusive access by a single process. So this kind of situation always happens with the mutual exclusion. So this was our second prevention. Next, move forward the hold and wait. So what is hold and wait? Hold and wait is a condition where processes always holding some kind of resources and also waiting for resources. So this was our hold and wait. How we will prevent hold and wait? Let's see. Here processes must be stopped from holding single or multiple resources while simultaneously waiting for one or more other. We will always try to neglect of holding the resources for a longest time because already processes are waiting to complete their task. Okay, in last we are having circular wait. What was the circular wait? Because processes are waiting for each other to be completed. So here how we will prevent deadlock from with the using circular wait? We always impose a total ordering of all resources types. Circular wait also requires that every process requires resources in increasing order of enumeration. Means we always try that this kind of situation will never occur. This is the last concept of deadlock prevention. Next we are having deadlock avoidance. So what is deadlock avoidance? It is a way to avoid a deadlock. Means we have learned about deadlock detection. We have detected how the deadlock is happening. We have learned about deadlock prevention. We were understanding the approach of how we are preventing the deadlocks, and here we are having deadlock avoidance. So what kind of approach we are using under deadlock avoidance? Avoidance means that we have seen that there is a deadlock, still we are trying to avoid that situation. So we are also use some kind of algorithm under this kind of situation. So it is always better to avoid a deadlock instead of taking action after a deadlock has occurred. It needs additional information like how resources should be used, Deadlock avoidance is the simplest and most useful model that each process declares the maximum number of resources of each type that it may need. Okay, so we have one algorithm for this, that is a Banker's algorithm. After this session, I will take another section in another day. I will teach you about the Banker's algorithm and its numerical. It's a very good approach to always avoid the deadlock. There we always try to have a resource limitation. We always look for the need and the availability of resources. So this is all about the deadlock avoidance. Next, we are having a very good topic, which is starvation. If you have any query related to deadlock, you can write over here. Then I will start with the starvation. If you have any query, you can write it over here. So I'm just moving forward. Starvation. So starvation is the problem that occurs when high priority process keeps executing and low priority processes get blocked for indefinite time. Okay, in heavily loaded situation or computer system, a steady streaming of higher priority process can prevent a low priority process from ever getting the CPU. Means here we can see that there is a CPU which is just executing all the processes and requests which is coming to it. Okay, Adarsh. So in this situation, all the process which are having some kind of priority, okay, this can be in increasing order or decreasing order. So here the CPU is just executing all the processes one by one, and already in this example you can see priority 1 is already inside the CPU and priority 2 process 3 and 5 is already waiting state. So let's suppose P2 is waiting for CPU and P3 is also waiting and P5 is also waiting. After P1 get out and P2 gets enter inside the CPU for execution, and P5 thinking that okay, after P3 priority 3 my chance is there. But in meanwhile time, let's take P4 means priority 4 kind of process is coming when P2 or P3 is under CPU, and means priority 4 higher priority processes is coming and lower priority is also inside already waiting, because P5 was already waiting for execution of P2 and P3, and P4 also came, and again because it is having higher priority and it is having lower priority, so it was already in waiting state. Again after coming of P4 and priority 4 request, it have to wait more. Okay, so in this kind of situation the starvation occur. I hope you have understand the concept of starvation. Means higher priority requests are just executing inside the CPU and the lower priority processes are already waiting due to some other higher priority process also coming, and the lower priority have to wait more again and again for indefinite time. This kind of situation always we can call it as a starvation. Let's move forward. What is the difference between starvation and deadlock? Because in deadlock we were also seeing that some kind of processes are requesting some kind of resources, and in starvation we have already seen that some processes are getting in waiting state for a longest time. So what is the difference between starvation and deadlock? So the deadlock is a situation occurs when one of process got blocked. Okay, and starvation is a situation where all the low priority processes got blocked and the high priority processes executed. Okay, we can see also the next difference. Deadlock is basically an infinite process, because deadlock is happening. We have some kind of methods to avoid, detect or prevent deadlock, but in starvation is basically a very long waiting state but not a infinite process. Okay, it can be a like indefinite time waiting state. So again we are having in deadlock, that every deadlock always has starvation, okay, but every starvation does not necessarily it is have deadlock. It's a very main difference between deadlock and starvation. Deadlock always have a starvation situation, but starvation will not always having the deadlock problem, okay. So in last we can say that deadlock happens then mutual exclusion and hold and wait and no preemption. Here you can write is a no preemption and circular wait do not occur simultaneously, but in starvation it happens due to uncontrolled priority and resource management. Here we have to always look for that if our lower priority process is waiting for the longest time, this is the main problem in starvation. So this is all about the difference between starvation and deadlock. If you have any query you can ask. Good evening Dilip. If you have any query you can write over here. So in last we are just discussing about the advantages of deadlock. What are the advantages of deadlock? You can see over here that always if we are having deadlock, that there is also some little bit of advantages. This situation works well for processes which perform a single burst of activity. Convenient method when applied to resources whose state can be saved and restored easily. It is also very feasible to enforce by compile time checks. And last we can say we can also say that it also needs no runtime computation since the problem is solved in the system design. So here are some basic advantages for deadlock. So let's move forward some disadvantage, because always we have seen that deadlock is also having some kind of situation where we have to just delay or block states. So what kind of disadvantage we are having with the deadlock? Deadlock always delays process initiation. It also here processes must know future resource need, because the resource allocation problem is there, okay, and preempts more often than necessary. Means if we are having some kind of situation that deadlock, the main disadvantage that we are just stuck in a state. If we have to clear all the problem, we have to go with 4 main conditions, okay. So it is also disallows incremental resource request. Processes are just requesting and just waiting for indefinite time. So this is the main disadvantage of deadlock. So in last I am just summing up all the topics. Okay Dilip. So what we have learned in this complete session? We have learned some deadlock, starvation and the situation to preempt, prevent and avoidance of deadlock. So here's a small summary for deadlock. Basically what is deadlock? Let's just recap all these topics. It is basically a situation that occurs in operating system when any process enters a waiting state because another waiting processes is holding the demanded requests or resources, okay. And also circular waiting happens when one process is waiting for the resources which is held by the second process, which is also waiting for the resources and held by the third process. That was our circular waiting, okay. So another point, a deadlock occurrence can be detected by resource scheduler. That was a very main point of that topic, okay. So this kind of point will help you to recap and revise the entire session in a small time. And again it is a very important to prevent a deadlock before it can occur. Prevention is very important. And let's go with the mutual exclusion topic. So mutual exclusion is a full form of mutex. It is a special type of binary semaphore which used for controlling access to the shared resources. Hold and wait is a condition where process must be stopped from holding single or multiple resources while simultaneously waiting for one or more others. So this was the hold and wait problem. And let's discuss with the deadlock avoidance. So what was deadlock avoidance? Deadlock avoidance was the simplest and most useful model that each process declares the maximum number of resources of each type that it may need. Okay, so this was the deadlock avoidance. So in next session I will also tell you about the Banger's algorithm, resource allocation graph. This will the next these topics would be the next session coverage. Okay, so deadlock, in last I can say that deadlock is an infinite process, where starvation is a long waiting but not an infinite process. So this is a complete summarization of all complete session. So I hope you have understood very well the topic of deadlock, and it's a very I hope you have cleared with the concept of deadlocks. So for more detail with the numerical concept of deadlock avoidance, we will take another session. I will inform you. So if you have any query, you can write over here. If you have any question, you can write it over here. Okay, thank you everyone. Jai Hind.